Welcome to another talk from Zurich Mainz. We have here Dirk Helbing. He is Professor of Sociology at ETH Zurich, and I'm very pleased that he is here and he can tell us a lot about complex system. Welcome, Dirk, to the show.
Thank you very much.
What are you trying to find out in your research?
Well, in principle, today we know a lot about the universe and how it works. We study the physical forces that keep our world together with particle accelerators and so on, but we don't understand well how society works and what are the principles that make our society work well. In fact, we have a lot of problems these days in the world. The financial crisis is just one of those examples really that worry us these days, and it's an example of complex systems, in fact. Complex systems behave in a completely different way from the systems that we are classically used to. They cannot be controlled or steered like a bus or so. Actually, they're hard to control from the outside. They're hardly predictable in their behavior. They have an eigendynamics. We often talk about emergent phenomena, which means that if many components in the system interact, then the system comes up with new properties, often in a very unexpected way, and that makes them so difficult to understand, in fact.
Give us an example of a complex system.
Well, complex systems occur in many areas of our reality. In physics, for example, we have turbulent flows. I've certainly heard of the butterfly effect in chaos theory.
So a little butterfly flips its wings and then a tornado appears somewhere in Texas.
Well, if we exaggerate a little bit, so small courses could have big effects in principle. And the same applies actually to financial systems, to traffic systems, to society and to our economy. So in order to understand those systems, we need to have new perspectives on these problems. Classically, we have a component-oriented view. That means we focus on our attention on what we see in the system. The people, the companies, the institutions, and so on. But what really matters in complex systems is the interactions. And that is the part basically which is hardly visible, it's difficult to measure and so on, but it's the basis of the self-organization and eigendynamics in the system.
But wouldn't we have to first understand how human beings work and then as a second part understand society? It seems like you're going the other way around. You're looking at society from the outside in instead of understanding first a human being and then projecting it out.
No, this is not actually true. We're doing these days a lot of experiments in the lab, in the web, in order to find out how people take decisions. And then the important point is how does the decision-making of many people create collective behavior, as we see it at financial markets when there's herding behaviors or when there's fashions and trends in politics and elsewhere, also in science, by the way. So collective behavior is what comes out as an emergent phenomenon from the interactions of the individuals, and we understand a lot these days about how social cooperation comes about, how social norms come about, social conflict and all this. So we do have a much better basis actually to study society, and we're doing it more and more by a combination of experimental methods, large-scale data mining and computer simulation.
What is the reason why finally now we are doing this work and we haven't been doing it in, let's say, the 50s or in the last century?
Well, basically in the social sciences it was much harder to get the data that were needed in order to understand what is going on. So that's why we somehow forgot to come up with a systemic science of our society while we were going on with the globalization and with technological change. We have in fact created a completely different system. It looks very much the same because the components are the same, but the interactions have changed a lot. So now we have a strongly coupled system. We have strong interdependencies between different areas of society. We have interaction between society and the economy, between economy and the environment. And all of that is coupled also to technology and so on. And so if we're improving one system, it can have negative impacts on other systems, because there can be negative side effects, there can be feedback effects, there can be network effects and cascading effects. In fact, many of the problems we're facing today are resulting from cascading effects. That means there is a local disruption and it can have a global impact in a completely different part of the system. Mm-hmm. This is what we need to understand. We need to gain this systemic understanding, and without that, I think it will be difficult to master our future.
Mm-hmm. You once said the sentence, we understand the universe, or we understand our solar system better than we understand society. So this is your contribution of understanding society. Of course, it's a huge task. You need billions of terabytes of data, transaction data. How do you go about it? You have this future ICT project. You have funding, or you're close to being funded, large amount, €1 billion, if it comes through. And what is future ICT, and how do you go about solving this huge puzzle of this complex world?
So future ICT will create new science and technology in order to manage our future in a strongly coupled world as we are facing it today. And so it will create new methods and instruments in order to extend our imagination, in order to allow us to explore the options that we have and the implications of our decisions and actions. And there are a number of different instruments that we are creating, as people have created telescopes in the past in order to explore the universe. So on the one hand, we will create a living Earth simulator. The living Earth simulator will basically extend the principle of simulation that we're applying in many other areas, such as whenever we create a new car, a new plane, or a new medical truck, supercomputers are being used for the design, for the testing, and so on. But this kind of supercomputers are not yet used in policy making, in decision making, in economics, and so on. So it's absolutely logical to transfer the principle and use the power of computers for a better decision making and planning. Mm. This is the one thing. So there are quite a few developments in the past to come up with models that allow us to understand certain systems, such as traffic systems, urban and regional development, and so on. So that now shall be scaled up to a global scale, and also the models will be made more and more detailed as data become available. We often talk in this context of policy wind tunnel, basically to test policies in advance through scenario simulations, or as a socio-economic flight simulator, basically. So we'll be able to explore much more what the implications would be of this option or that option. Mm-hmm.
What do you think, in the best case, in 10 years from now, what will we be able to do with this Earth simulator, or policy simulator, or socio-economic simulator? Give us a scenario of the best case, what could happen?
Well, I think what is really important is that we become more aware of the actual state of the world. And I'm not only talking about the physical state of the world and the environment, but also about society and the economy. The state of the society is much harder to measure. So there is a number of things that are extremely important for